Go ahead. Perfect. Sharing screen. Okay, team. Do you see my PowerPoint screen? If yes, I need 2 thumbs up to start. 1. Mohit, 2nd. Yeah, Cora, thanks you all. Okay. The last time we have already discussed more about string, and we talk about vector, and we have already discussed vector, that it is a data structure, a data container, that we can use it when we need a flexibility with the size. We don't have to make a predefined for the size of the data structure. When I use the word data structure, which means that it is a data container. A variable is a data structure. An array is a data structure. The vector is a data structure. Maybe later you will learn about stack. It is a data structure. So there is different data structures in all high-level programming language, not only in C++. However, today we will learn something that is somehow, it is very specific to C++ and C also, because C++, as we said from the beginning, the origin of the C++ was C programming. Pointers. Pointers concept that we are going to discuss today, and we will have different exercises. And as I said in my email, that live session, yeah, it is optional. It is highly recommended. You can join the live session and you can stay with us till we make the group work, and you can leave before. And the group work at the end of each live session will have a bonus. I have already taken a note for the bonus for the last week, and today there will be another bonus. So who will stay till the end of this lecture and will participate in the group work, and at the end of this group work we are going to deliver a reasonable solution. Doesn't have to be 100% correct. However, it has to have, because you will have a short time, it should somehow has a solution that is acceptable with a very good logical manner. Logical manner, which means that I want you to learn how you have a logical thinking, how to deal with different problems and propose different solutions, even though sometimes the syntax will not be so correct. However, the logical thinking for the structure of your code and the different hierarchy that you are going to propose within the code, it will give me a good image about the level of understanding for you concerning how you are going to think in a very good logical manner to deal with different problems during this course or when we're dealing with any programming language in general. Pointers, it is the main difference between Java, if you are going later to learn Java, and C++. Java doesn't have the concept of pointers. C++ has the concept of pointers. Later, when you are going to learn about OOP, object-oriented programming, the C++ and Java is going, both of them, they are OOP language. However, if you are going to point for an object is being already created, or a variable, whatever it is, you have to create another object in Java. Here in C++, no, there is a concept of pointers. So let's learn what I mean by concept of the pointers. It is very important to know this. If you have any question during the live session, stop me and ask me. This concept is very important for professional in programming. Many people, even though they will have they have some years of experience, however, still they can't know how to deal with pointers. So it's very important now to learn the concept today, and I'm happy to answer all your questions concerning this topic. So why we need pointers? So pointers, we are going to use it to make a good memory management, especially when we are going to deal with dynamic variable and dynamic array. We will talk about it at the end of this lecture. So it helps us to deal better or manage the memory space, that we will have it in a better way. When I talk about the memory space, you know, all of you know that our computer has different memory types. It has the permanent storage, like the hard disk, and it has the temporary one when you run a program, which is the cache of the CPU plus the RAM. I'm talking now more about the RAM. It is a temporary memory, and it is the fastest one, that during running different programs, you are going to deal with it. So this memory, it's not like the storage, the permanent memory or the storage or the hard disk. It is very limited. Most of the computers will be now 16 gigabyte, 32 gigabyte. So it is limited, not like when you the hard disk, you have a tera of byte. So this is why, if you are going to make a very professional program, the memory management and the memory usage, it is a key point you have to take care for this. So we know a variable. So far we know that what is a variable. We know that a variable, there's a data container that we are going to use it to save a data in it. However, a pointer, let's say it is a variable also. However, this variable will contain the memory address to another variable. Let's see here. For example, here, this is your memory space. You have a variable v1. You have already declared this variable. And the variable, suppose it is an integer, you have already saved 7. Number 7. And this variable will take different space, or will allocate different space in the memory space based on the type of this variable. At the beginning of this course, we have already discussed that there is integer, float, double, short integer, long. So each one has a special size. And when you declare a variable with a specific size, there will be a size allocated to this variable, even though you are going to use the whole size or not, there is a size that is being already allocated. So you have here a v1, and then you have a value v7 here. P1, which is a pointer, here suppose it has a memory address. We know that what is mean by memory address. That our memory, it has different slots, like, so suppose that each slot will be 1 byte. Then each slot, it has a memory address that you are going to access it, or your operating system is going to access to it to get the data as being saved here. And again, maybe the variable itself can occupy more than one slot based on the type of the variable. So here the pointer is not going to hold a data, it's going to hold the address of this variable. So this is pointer point to this variable because it saves the address of this variable in this case. So far we have a new concept, pointer. We have a variable, the normal variable that we know before, that it holds data and it occupies a space on the memory based on the type of the variable. And now we have a pointer that only will hold, so it will have a fixed size because it only holds the address of this variable in this case. Okay. Again, we will understand more Why we need to have pointer? At this level, I want now to understand more and discuss with you more what is a pointer, how we declare a pointer, how we use a pointer, and at the end, we will understand more what is the motivation from having this kind of pointers. So, how we declare a variable, a pointer, it's somehow similar how we declare a variable, which is that we have first to give it a specific type, the same like integer. And if it has to point to a special variable that it should have the same type like the variable that is pointing to it. So here I declare P, I name it pointer P, the type is double, and we have to use this asterisk. So this symbol, we have to use it to tell the compiler that this is not a variable, this is a pointer. So, and it should have a type, and it should and when you are going to use this pointer to point to a special variable, it should have the same type like the variable you are pointing to it. Here, you can see that we can have like the same when we make the declaration having different variables, that we can do it in a one line. The same here, we can do it for pointers and variable at the same time. When here I make this declaration, which means that I have the compiler will understand that I have two normal variables and I have two pointers. All of them, they have a type integer in this case. Now there are two operators that we have to deal with them when we talk about pointers. The first one is we name it reference operator, and the second one is named dereference operator. Let's talk about reference operator now. Reference operator, when you will use it, this means that here we just declare the pointer. It is the same when we declare a variable, but we didn't assign any value to it. Here we declare a pointer, but we don't assign any reference to it, which means so far it doesn't refer to any variable. When we use this operator, the reference operator, which is the and sign, it will mean that this pointer is pointing to this variable. This means that this pointer now can hold the memory address where this variable is being stored. Again, using this reference operator means that now P1 will point to V1 when I set point, which means that it will hold the memory address of this variable. Like the same example that we have already seen it at the beginning, that here I declare a variable V1, and then I declare a pointer using this symbol, asterisk, and then I said, okay, using now, I said I assign a value to this variable. So in the memory space, it will take a slot of memory based on the type of the variable. And then I said, okay, P1 now, I use the reference operator, now P1V. So P1 will point to this, which means that it will hold the address of V in this case. Again, I said, so far, you maybe some questions come to your mind. Okay, why I have that pointer since I have a variable? So I have a variable, I'm using it, I'm storing a data in this variable. Why I should have another pointer that point to it? Wait, we will see how we are going to benefit from this variable, especially when we're talking about memory management. So now there is another operator that we have to deal with it when you are going to deal with a pointer, dereference variable. Dereference variable, so as so far that we have, that's the same like when we done before, that declare a variable, declare a pointer and a variable, assign a value, and then they make a reference using this. So if we use the P1 and print out, the P1 will have 174. It will be in hexadecimal, by the way, but I'm putting just numbers here to simplify the idea. However, really it is hexadecimal when you are dealing with a memory address. So here, when I print out the V1 have 7, but if don't mix between when we declare and using this star sign or asterisk sign, and when we use this when we are calling the pointer. Here, when we declare it, we put it, which means that tells the compiler this is a pointer, not a variable. But when we are going to use it here in our code, if we use it without a star, after we assign to it a reference, then mean that here we are going to return the address. If we use it with a star, this means that we are going to return the value where it had a reference to. So the dereference operator, we name it dereference operator. We name it reference operator. So don't mix between both of them. So again, when we use it as a pointer to standing alone after using a reference operator, which means that refer to this, this means that we are going to get the address of a variable where this pointer point to. If you use it with a star sign or asterisk sign, in this case, we are going to get the value where the value of the variable where it point to. So without a star, it will return the address of the variable where it point to. Don't mix between them. And with a star, it will return the value where the variable it point to. But in both cases, you have to make a reference to it. This reference makes this relationship between the pointer and the variable. After you establish this relationship, so you can get the address of this variable just by calling the pointer name, or make a star before the pointer name. In this case, you get the value of the variable. We name it reference, which we use it to make a reference between the variable, between the pointer and the variable. Here we name it a dereference operator. We use it to get the value of the variable that is pointed by this pointer. See this now. So when we make a print out of star P, we get 7. See this now what happened. Here we assign value to star P1, we name it 10. Now in V1 there is 10 also. So I can use the dereference operator in two ways. Either I get the value that is saved in the variable that this pointer is pointed to, or I will assign a value to the variable that this pointer is pointed to. Here I assigned a value to it, like here. Before I will write this code, there was 7 in V1. And when I call this, I will get the value here and print it out. Now, I have assigned a value to the star P. Star P, again, will return to me the value of the variable that I am pointed to. So in this case, the variable that I pointed to, using this line of code, will now hold the value that is assigned here. So star pointer, I can use it either to get the value of the variable that pointed to, or assign a value to this variable in this case. So now I will print out the V1, I will get 10. And again, if I print out the star P1, it will be 10 because it will print out the value that it is in V1, and the value now is 10 because I assign it here using star P1. Pointer assignment. Okay. Suppose I have already declared two pointer, P1, P2. And if I set P2 equal P1, I didn't use a star. Suppose I have already assigned pointer, I created two pointer and P1, like here. P1, I make a reference to V1, to V, sorry, or V1. Here to be V1, by the way. So if I said P2 I have already declared, but I didn't refer it to any variable. So in this case, if I said P2 equal P1, not the star P2 equal P1. So if we don't use a star, as we said before, if you don't use a star here, this means that we are talking about the address of the variable that it's pointed to. So I didn't use a star here. So in this case, P1 like this, it will return to me the address of the variable, the memory address of the variable pointed to. In this case, P2 and P1 is going to point to the same variable in this case. Because I said I declare a pointer P2 an integer, and then I said, okay, P2 now pointed P2 equal P1, but I didn't use a star before this, which means that P2 is going to point to the same address where P1 is pointed to it. However, if we use star before, if we use it before the pointer name, this means that we are talking about what? About the value where it is, where this pointer is point to. So if let's take this example. Suppose that, forget now this. Suppose that you have P1 equal P2. Before we write P1 equal P2, there was P1 pointing to a memory address that where is 84. Suppose this is V1 and this is V2. And P2 is pointing to another memory address where there is 99 value. This is a memory address, and this is a memory address, and it holds a value. If anyone have any confusion what you mean by a memory address and how the memory address of the computer is being already constructed, or this memory address, how it is, go ahead and ask me a question. Memory address, it is a matrix, like a matrix, where each cell has an address and it can hold a value. This is a memory address, how it is. This is the logic construction or the logic high structure of a memory space in our computer. Again, when I'm talking about the memory, I'm talking about the temporary memory, not the permanent memory. So before we call this line, this is the situation where P1 is pointing to a memory space or a memory address that hold 84 as a value. This is V1, V2. And then after I call P1 equal P2, this means that I don't use a star. So if I don't use a star, this means that I'm talking about the address, memory address, not the value. So if I said P1 equal P2, which means that the memory address that P1 is going to point to it is the same memory address that P2 is already pointed to it. So in this case, P2 is already pointed to V2, and then P1 will point also to V2 in this case. It will not anymore point to V1. And you can see now, even though it's not so clear what is the benefit of the pointer, but we can see that pointer is very flexible. If you are dealing only with a variable, it has a fixed memory space, it has a fixed address, and it can have either you assign a new value or delete the old value, then assign a new value. However, here pointer, no. it can point to this memory space, then it can point to another memory space, and then point to another third memory space. It doesn't mean that we are going to point it. If it is, by the way, a variable name like v1, we can name it as a constant variable, a constant pointer, because it points to a memory space, but is constant. It is not flexible. It cannot, v1 and v2 here in this case, I can name them. We name it variable, but I can name them as a constant pointers because they point to a specific memory address where they hold a data, and they can point to another memory address. A pointer not like this. Pointer, it can point to any memory address based on what you are going to write in your code. So here, after I run this line of code, P1 will point to the same memory address where P2 is already pointed. So if this is V2 and this is V1, P2 is still pointing to V2. So in this case, P1 is going to point to V2. And if after this line, we will make star P1 get the value where this pointer is pointing to, in this case, we'll get 99, not 84. However, if I have this like this, P1 again pointing to V1 and P2 pointing to V2, and I'm going to execute this line, star P1 equal star P2, what will happen in this case, when we talk about a star, we are talking about a value, not about the address. It's too easy. Star value, not address. So if I said star P1 equals star P2, this means that I'm going to assign the value that is being already in the memory space address where P2 is pointing. I have to take the same value and put it in the same memory space where P1 is pointing. Because I said star P1 equals star P2, so still P1 is pointing to V1 and P2 is pointing to V2. However, the value in the memory space, whereas P1 is already pointing to, is going to hold 99, which is the same value that P2 is already saved in the same memory space address, whereas P2 is already pointing to this memory space address. No questions so far? If there is no question and you want me to continue, I need 2 thumbs up. Or I will stop. If I stop, that means that I have come to ask you. Okay, so how we are going to use, so I see that many people are doing thumbs up in order not to be asked, yeah? So how we can use a pointer to in function. So now we have already seen how we can use pointer with variables and pointers between each others. How we can use this to a function, because we know what we have already discussed so far, even though we don't make so much practice. In the next assignment, you are going to practice more, because I should send an assignment 2 in this week. And always I will give you 1 week more. So if I send it in this week, I will give you till the end of the next week. So you should expect that you are going to have an assignment this week, assignment 2. So we know from the function that we have already discussed before that when we are going to declare a function, we declare function name and the arguments. What is the type of the argument? What is the input for this function? And also we declare the return value of this function. So we can build a function that can take a pointer as an argument, not a value. So now we have 2 types of function declaration. The first one, the old one that we know about it, passed by value or passed by address. Passed by value, it's like the old one, which means that you declare a function. You declare that this function will take a value And then it is a variable, because when you talk a value, you are talking more about a variable. So, and if you are going to call a function using pointer, you have to use a value, star value, star value, star value. So because it's being already declared that it has to pass by value, like the old one that you have already seen before, here when we don't mix between declaring a function and calling a function. Declaring a function, which means that you are going to define what is the input and what is expected output and what is the name and what is the return value type of this variable. Calling it when you call this in the main function. So when I'm going to use a pointer and I have to call this function, in this case, if I'm going to use a pointer, I have to pass the value of the pointer. So it is a must. If I pass it without the value of this, then I will get an error in this case. Because when this function was declared, it was declared to take a value, not to take an address or a reference. Passing by reference, which means that here, then when this function is being already declared, it will not take the value, it will take the address of the value. You see here how it's being already declared? That it will take a pointer, not take a value. And again, star sign don't mix it. When you are going to use a star sign, when you declare a pointer, this is not a dereference operator. This is assigned to tell the pointer that this is a pointer, to tell, sorry, the compiler that this is a pointer. But after you declare a pointer, if you use it before the pointer name, that means that you are passing the value of that is assigned with the memory space where the pointer point to. So if I want to pass by reference, which means that this function take the reference of the pointer. So like here, I have already declared and defined how the function will work. Here, when I call the function, so you see, I didn't pass star pointer, which means I passed the pointer name. This means that I passed the address where this function already point, or I can use directly, by the way, this sign with the variable name, which means that passing the address of this variable is being already saved. You know, here this is, so when I said an address, here we'll have an address, and I have a data in this address. So when I create a variable like num1 equal 1, so it will be saved in special address space, will have a special data. Here I declare a variable, for example, here. This variable, the memory address where it is being saved, 1110, and here this is a value that's being saved in this memory space, which is 10. Here when I create a pointer, so it is like a variable, it will have the pointer address. It has a place in the memory space. However, here it will hold the address of the variable where it is pointed to, because here we use, don't forget the name, reference pointer, which means that pointer, when we declare this pointer, here we declare it, but there is nothing here. When we make a reference, then the pointer now refer to this. So here, in the pointer will hold the address of the variable that refer to it. And here, as I said in the function, if it is a function, when we declare it, we use the reference, which means that when we call it now, we have to call it with a pointer name. We can't call it like this, star pointer, because if we do this, which means that we are passing the value. I know it is confusing. You are going to be confused with the star sign. Here, this is the reference operator. It's so easy because it's now, we use it to get the address of this variable and we assign it to this pointer. However, when you use a star sign in declaration, you are telling the compiler this is a pointer, that's all. When you use a star sign before the pointer, when you are using this pointer in your code, which means you are talking about the value that is assigned to this pointer. So here, because when this function is being already declared, it was declared to pass by reference. So when we are going to call this function, we have to send the pointer name, which is the reference, not to use a star with before the pointer, then it is the value. Star value, star value. So this already has discussed now here. Good. The first exercise for today. Based on what we have, I will help you. I will cheat you. So I will cheat with you. So now we have these two programs. There is an error here. More than one error, not only one error. Both. Let's start with this. Based on what we have already discussed, this code will not work. And if you are going to write it now, this code, we will get a build error. Why? Why we will get an error? Any volunteer? I will help you, don't worry. So any volunteer, if you have any idea, I will give you 30 seconds to think about the first one. Forget now the second one. Let's go with the first one. Think with the first one, I will help you, don't worry. So just think, what is the error here? Why? Based on what we have already discussed about the pointer concepts, about the reference dereference pointer. So, reference dereference operator. What is the error here? Ten seconds more. I will choose a volunteer in this case. Kura, are you here? Can you hear me, Kura? Are you here? Oh, maybe there's something typing in the chatting. Yes. Do you have any answer? What is the error in the first piece of code? It seems not. I will help you, Kura. Kura, if, for example, that here, so far, it's okay, I think, because here we have already declared a pointer. At this line, we tell the compiler that p integer, it is not a normal variable, it is a pointer. Because when we declare it, we use this sign. However, we can't assign a value to it if it does not refer to any variable. A pointer should refer to a variable. We will see a special case later. Maybe it will refer to a unnamed variable or a named variable. But how I can assign a value to a variable, to a pointer that is not pointing to any variable? Don't forget, here the memory space that we will have it. Here we will have different memory space address. And when we create a variable x, it will have a memory space address and the size of this memory space based on the type. Like if it is double, it will have, for example, 8-bit or whatever it is. If it will be float, it will have less. If it will be integer or short or long, it depends based on the type. So, and then I can store a value for this assigned to x when I said x equal 5. Here I create a pointer. I name it pint. However, to assign a value to this pointer, so it first should point to a memory space address. Here it doesn't point to any memory space address. So in order this code to work in a better way, I should set integer x equal 9. And then x will hold here, for example, 9. And then I will set p int using a reference operator, which is the AND one. Okay? Using the AND one, I said x. Now, this code will work because I assigned a value to a variable, and then I refer this pointer to this variable. So when I will print out star p int, star, when I'm calling, when I'm using it within the code, the variable, I'm calling it, and the star, then I'm talking about the value. So now this will be correct. Why? Because p int is pointing to a memory space for a variable x where there is a value. So it will print out 9. So the error was that we don't have this, should first assign a variable, and then we will point this pointer to a variable in order to work. Yeah. I'm sorry, it seems that, yeah. I didn't see the chatting. Yeah. Sorry, it seems that I didn't see Viraj and what you have already seen. Yeah, now open the chatting. I don't know. So I think now it's clear. Okay, now I need a volunteer for this. Here we have an error also. Who will be volunteer here? Do I have to choose? I don't like to choose. I don't want to put you in to be embarrassed or something like this. So. Okay, since you, Viraj, you have already given a solution, I didn't take care for this. Sorry for this when I was discussing. Go ahead, Viraj. Can we talk with the mic, Viraj?
Yes.
Yeah, how are you today?
Yeah, I'm fine.
How was your holiday?
Well, good. I'm in India and right now it's
Yeah, there is no
10.
holidays there. You are
It is,
planning to come here to Canada next semester or?
no, yes, in the next month, probably.
So maybe next month we can know you face to face in this case, because I expect that all of us will return to campus.
Yeah, sure. So in this program, the error is in the 9th line, p where is equal to 9. It should be star p where is equal to 9.
Here, you mean here? Here, is this one?
Yeah, star.
It should be
Star
what?
p where? Star.
Star. Here before P, I have to use star.
Yes,
like
yes,
this.
correct. Yes.
That's all. There is more error here, or you can see it's everything okay.
I think everything is okay.
Let's go line by line. So here we will declare a variable. We name it some variable 5. Going back here, let's go to our memory address, memory space. So we will have here. Okay, now we'll have a sum variable. I will write it sum as v. It has an address space and it holds a value 5. See out, there is nothing. See out, now you are printing out the variable, so I don't. This is okay. This is okay. Now here we said
p where a star should not included. P
Sorry?
where is equal. I think that P where is equal to add the star before the
You are
P.
talking about this line now, Viraj.
Yes, yes, yes. I think that.
No, it's okay. What is you see there is an error here?
I think that star should not be included.
Why you have to no, we have to declare the pointer.
Yeah, I'm confused between this.
No, in this case, I said during the lecture that there are something confused with the star sign, that when you are talking with a star, when you are going to declare a pointer, you have to use a star sign to tell the compiler this is a pointer. So I think this is correct, because we are telling the pointer that this is a compiler that this is a pointer, not a variable. So you have to use a star sign here. And then when we use the reference operator, which means that making the relationship that this pointer is going to point to this variable. So as you said, that if we make a p-var9, what will happen if we make a p-var9? This means that p-var are going to point to a memory space where is the address 9. We are not going to put in some variable value 9. If we use again star value, no star talking about address. So if we are not going to write no star here, we are talking about the address of the variable or the memory space where we are going to point. So if we like 9, in this case, p-var will not anymore point to some variable. However, if we are going to change the value in the variable where p-var is pointing, thank you, Viraj, as you said, that we are going to put here star. Because by putting a star, we are talking now about the value of the variable where this pointer is pointing to. So yes, there should be a star here, 9. In this case, the sum variable will hold 9 as a value because we use a pointer that pointed to it and assign a new value to it using star p-var. Thank you, Viraj. I will add later the solution to there. Okay, now I have more exercises now. Now the exercise is about true, false. It will be easier. So I want to know it is true or false, and if it is false, why it is false in this case. So who will be the next volunteer? One is true. Let's say, yeah, 1. A pointer is a variable that holds the address of some other location memory. Yeah. Pointer holds the address of other location in the memory or variables. Thank you so much, Lisa. You are 100% correct. Yeah. Let's go to number 2. Number 2 say pointer variables are just memory addresses and can be assigned. Pointer variables are just memory addresses and can be assigned to one another without regard to type. I don't know if it is clear. It's saying, let me clarify it more. It's saying that pointer variable, false. Go ahead, Raghav. Yeah, you are correct. And also Lisa, you are both correct. So pointer, yeah, they are just memory addresses. Yeah, this is correct, but should be assigned to the same type of the variable that they are pointing to. So integer point to integer, double point to double, float to float. So it is false because they should have the same type, as we said in the lecture. 3. The declaration below declares 3 pointer variable, type pointer to double. Is this declaration correct? If I want to declare 3 pointer and 3 they are double, is this declaration correct? Yes, no. False, Viraj. Perfect. Why, Viraj?
I think that we have to declare every pointer to star P1, star P2, star P3, because
thank you so much, Viraj. Yeah, and also Lisa said this. So asterisk should be before each one of them. So, because again, when we declare a pointer, we can't declare it as we declare variable. So this means that we are declaring 1 pointer and 2 variables. However, we need 3 pointers. So the compiler, to know that these are pointers, we are going to use a star sign before each one of them. So we have to put a star. Thank you so much. I'm happy that you are answering the question in a very quick way. This means that what we have already discussed so far in the lecture is somehow clear to you. So as we said, this is true, false, false, and this is, we have already discussed this. Now let's talk now about what we have already discussed concerning the pointer concept, that it is point to a memory address, it can hold a memory address, and also we can get the value using star sign, reference, dereference operator. So what we have already discussed so far about pointer. Here in this part, we can understand more what is the benefit from it. There is something, we name it now dynamic variables and array. Dynamic as a word means that we are more flexible and less restriction. However, here we are talking about dynamic, about the memory space. Let's see more about how we can declare a dynamic variable or dynamic a pointer that we can use it for as a dynamic variable. What we have already discussed that as examples that we corrected it because there was an error. Sorry, we said that you declare a variable, you declare a pointer, and then you refer this pointer to this variable. Suppose that I don't have a variable. I want to create a pointer and assign a value to it. In this case, you can use the word new int. New int mean that new int mean that this is here because I'm not declaring a variable like before, making integer, make sign p, and telling the compiler that this is a pointer. Here I'm declaring a pointer, but I'm assigning to it to a nameless variable. So using this word new let the compiler understand that this is a pointer, not a variable. And this pointer is, again, and this pointer is assigned or, refer to a nameless variable, not a specific variable. In this case, we name it dynamic variables because there is a variable is already created. There is already a variable, but it is nameless. And in this case, what I mean by nameless variable, that there is a memory space allocated to it and pointed by this pointer. Because if you are going to save a data, you are going to allocate a space in the memory space. Okay, so what? Okay, so it is the same like a variable. rather than creating a variable then refer a pointer to it. So you are now creating a pointer and referring to a memory space address, but without giving a name. So what is the change? Why you name it dynamic variable? But understand more now what I mean by this. Going back to the memory space in C++, and this is managed by the operating system, by the way. This memory space that in our computer, it's being divided in 4 categories. One, we name it Codespace, where the syntax of your code is being saved. The syntax. If, else, while. This is a syntax, the all lines, because these lines, they are word. Your code should be saved in a place while you are running your program. We have a stack. This stack, we are going to store the local variable and the path parameter. Local variable, the variable that we use it within the same function within scope. We talked about it before. And the argument that we are going to pass it, this kind of variable. There is another portion in the memory space we are going to save the global variable. The global variable that we, for example, at the beginning of our file, we declare it. It is not within a special scope or special function. It can be used by all of them. And there is something we name it heap or free store. Both name somehow they are used in the same manner. The free store or the heap. This memory space is the bigger comparing to other, and it's used to such kind of dynamic variable. Why? Because let's first take an example, understand more about what I mean by why this has a bigger space. You can see here's a space. Suppose now you have this, you have this program. This program has a main function, and then you have 2 functions. In these 2 functions, you have here a local variable, and here is a local variable, and here is a main function that where you call these functions. So in the code space, where you are going to save the words that are being used and the syntax, we are going to use to save this. In the global space portion, there is no global variable, so it is free. In the stack, where we name there's a global variable, the local variable, when you call this function here, then this variable will have a value, then you are going to use a stack for this. And again, if you call this function, then you are going to use a stack here for this local variable. So here we didn't use the free space or the heap because we didn't use pointers. Okay. So what will be the importance of the dynamic variable in this case? The importance of this dynamic variable be in this case that, let's take this example, and in the next function, the delete one, I will talk more about what I mean by this. And here we can see something. Suppose that, let's go line by line here. I declare 2 pointers here, but I didn't assign any value or or refer to any variable. Here P1 is a new integer. So P1 now is a dynamic variable. I assign a value to P1. I name it 42. P2, so here, when I created P1, new integer, I refer it to a memory space that has no name, but the memory space now is being already created. And the space of this memory space is created based on the type that I have already allocated. So when I said assign 42, again, star means talking about the value. I will put in this memory space 42. Here, when I talk with P2 equal P1, I am now both of them, because I didn't use a star before, so I'm talking about the address. Both of them will go to the same 42. You see here, this line, this is a more important to me. I use the new integer again. What does this happen? What does this mean? This means that this 42, where it's being already here, this is now 42, or here 53. It doesn't anymore this pointer. That doesn't mean anymore this pointer is assigned to this memory space, and I assign it to a new memory space. If this doesn't exist now here, for example here, suppose that P2 doesn't relate to this, we don't have P2. I'm just here this example to tell you how each line, how you can see what's changing here. But if this P2 is not here, and I recreate P1 with a new memory space, this means that the old memory space, if it is not referred to anyone, does not anymore exist. I can delete it in this case. Let's see here, this delete P. This is the main one here, delete. This is a main difference between a dynamic variable and a local variable. When I create, for example, I have this piece of line. I make an integer x. This is a local variable. I assign 0 value. And then I create P. Integer variable. Then I said I can create it as P as a new int, a local variable. Let's see in the memory space what's happening. We said in the memory space we have 4 portions. This is a free one, and this is let's say this is a stack. When I created X and put a value, so it will allocate a memory space for X. And now X will stay and will preserve this memory space till the end of this program. I can't do anything. It will allocate the space till the end of the program. Here, let's see this now. I now integer star P equal new int. Now P as a pointer will allocate a space here. And then I said, okay, P, I'm talking about a value now, P equals 6. So here will be 6. Then I will use different other statement. I will not anymore want P. Like, suppose that you use a temporary variable. I can go and make a delete of P before the program is being end. And so this memory space now is free. And then I can create another pointer, or I can't, or if I don't want anymore any pointer, I will not create it. In this case, while I want you to hear this, it's very important. If you can't understand it, ask me again, I will clarify it another way. By creating a pointer and deleting it, and creating another pointer and deleting it, what I'm doing this now that I'm using the portion, the heap or the free store, in a way that I will not allocate a space always. I will allocate a space, refer it to a pointer, And when I'm done with it, before my program end, I will delete it, and I can use it by another pointer, maybe with another type. However, if I allocate a variable, local one, not a dynamic variable. Dynamic variable mean a pointer, again, dynamic variable, a pointer pointing to a nameless variable using new int, new double. So if I use a variable and allocate a space to this variable, this space is going to be allocated and occupied by this variable till the end of the program. I can't use it to another variable because I have already created this variable allocated this space. However, if I make a dynamic variable and use a special space to a special dynamic variable, I can delete it and then use the same space. Maybe this is the operating system will manage this, but this space can be used by another pointer by another type during your program. So this is the main concept about the pointer. And this is why when we create a pointer without assigning to it to a special variable, we name it a dynamic variable, we have a better usage of our memory space that we can use. We can create a pointer and delete it, create a new pointer and delete it, create a third pointer and delete it. And now I can use my better space in a better way in this case. Is this clear about the concept of dynamic variable, where it's being saved, and how we can benefit from the pointer in this case to use our memory space in a better way? If it is okay, I need 3 thumbs up. 1, 2, 3. Okay. Yeah, there is a question. So we use a pointer only for a specific function, we need it, and then we delete. Yeah, this is a point. That if you are going to be a professional in your code, go ahead and use more pointers than variables. And during your code, if the value are not going to use it more, so you can just delete it and you create a new var. And if, for example, you need a memory space to an integer value, you create a pointer, new int, and then you finish. You can delete it, and then you can create another pointer to another type. So in this case, you use your better, so you use your space in a better way. Now with the group work, we can see this. I will ask you about this. So you are correct, yeah. You have always to delete pointers that you are not going to use it more during your code. Okay. Here is another example about the delete, how we can use it. Here are the examples that the same what I have already discussed before that. Int local variable, I create a local variable, then I will create here a pointer that refer to this local variable. Here, I create a pointer that is assigned using new int, which means this is a dynamic variable, and I can delete it at any time during the running of my code. Here I have already deleted it. So maybe here in this example, okay, I delete before the end, but normally if I have a very long code, I can delete with them, then I can create another one, delete and create and them, so I will not have an overload in my memory space. Okay. There is another point about when we, this is just a shorthand, let's say. What I mean by shorthand, that sometimes rather than going, if you have a special integer or a long integer or unsigned integer, whatever it is, the type, and rather than each time that you, like here, that you make an integer star that you are declaring a pointer, type integer, you can type def, which means that this integer pointer, you can give it a name, and then you will use a name before P. In this case, you are telling the compiler that this is a pointer with this type that you have already defined. So it's just a shorthand. You can sometimes we use it when we will have a long, like we said, a long type, unsigned long double. So rather than always when I use it writing this 3 word, I can make type def unsigned long double star P and give it, for example, D, P, 2 character that talk about this type. So type def, you can use it as a shorthand that to give another name for the type of a parameter, of type of pointer, sorry. The last part from today's lecture, it is about dynamic arrays. It's the same concept like dynamic variable. Again, dynamic array doesn't mean that it has a dynamic size, not like the flexible size like the vector. Dynamic array, it is the same like an array. However, the size that will be allocated in the memory space, it will be dynamic based in what you are going to put in this array. So it's more about allocating the space in the memory space, the same like the variable, which means that we are going to use the dynamic or the heap or the free store in the memory space for this array, not the stack for the local variable. So dynamic array, we are going to declare a size, but the allocated size, it's based on how much you are going to use. It's not like a vector. A vector, if you remember, it will take as much as you want. However, you should have already allocate a capacity. And this is one of the main disadvantage of the vector, that you should allocate a capacity for it in order to not, we have already discussed this last time, to make a reallocation. Here, dynamic array, also, it is not like a list array. Like a list array, or that maybe later we are going to discuss it. List array, maybe that you are going to create list array, you can create an array list without giving or defining the size of this array. Here we are going to define the size of array, but using the concept of dynamic variable. In this case, the space that's allocated in the memory space for this array will be based in the usage of this array. So it is more about, from memory management perspective, when you talk about a dynamic array in this case. Dynamic array, like if you remember here, this is a normal array, and this is a pointer. So here, I will create an array, and I create a pointer, then I point this pointer to A. By the way, A, the variable name of this array, it is a constant pointer. If, for example, this array is an integer and will have 10 elements, so A will point to the first element in this array. So it is a constant pointer. We don't know this before, but because now we know the pointer concept, so we can understand it in a better way. However, when I said I create a pointer, not a constant pointer, a pointer, and I said PA, I didn't use a star value, no star, we're talking about address. So I said P equal A. When I said P equal A, which means that P is pointing to the same address space that A is pointed to it. In this case, P will point to the first element in the array. Let's see here, understand more here about it. I create here 2 pointers, P pointer and P pointer 2. P pointer is dynamic variable, because when I created it, I didn't refer using the AND or the reference operator to a special variable. I refer it to a nameless variable, so it is a dynamic one. The value that I'm going to save it later, it will be in the dynamic portion of, or the heap, or the free store of the memory, of my computer memory space. So here, p pointer equal new integer. So first dynamic variable. You see here, the second pointer, it referred to new unsigned short int2. So I use also the new operator, but to refer to, you see this nameless array. So it is a nameless variable that somehow point to an array. So new short int, now I'm talking about dynamic array. So this is dynamic variable, and this is dynamic array. I have to tell the compiler that it should have two element. However, it is dynamic. And the value that's being already saved here is going to be in the free store, which means that I'm going to save it there. And when I deleted it, like here, so the space, it will be free, it will not be anymore occupied. However, if I didn't use a dynamic variable, dynamic array, and go like here, say integer A10, in this case, this space will be occupied till the end of my code. So pointer P, which is a dynamic, it will hold. Let's suppose, I'm talking about suppose that here it holds A004. So, and here pointer 38800, here again, the size of the memory space that will be allocated in a dynamic way, it will be based on the type. Don't forget this. And when we are talking about a pointer that point to an array, it will point to the first value in this array. If this value will be also integer, so it will take, for example, suppose that it will be 4 bytes. And later I can delete this, and then I free my space. So I can have a dynamic variable that I will, in dynamic variable, I will allocate a space based on the type. And in dynamic array, I will allocate a space based on the usage. And this pointer, again, this pointer will point to the first element in this array, and then you can go to other element. And when I will delete the pointer, the space that I use, it's now free to be used by somebody else. And again, if I delete it also for the dynamic array, it can be used. So this is here. This is here we can see the benefit of the pointer, where during the executing your code, this pointer is not anymore being needed, deleted, free space, deleted, free space. We can do this with a local variable or the local array. This space will be occupied till the end of the program. So again, dynamic array. So suppose that if the user has already, if he uses a local, not the dynamic one, and the user estimate too large, it is a memory wasted because he allocated this the whole one, and this is the whole one is now being allocated till the end of the program. Maybe he used 1, 2, 3 element, but he create an array of 1000 element. So now in this case, we lost a lot of memory space without using it. When we talk about memory management and memory space, it's very important because we are not talking again about the hard disk or the permanent memory. We are talking about the temporal memory. And most of the devices will have a temporal memory with a limit, 32 giga, 16 giga, whatever it is. So if you are going to write a huge program, maybe we are writing very small programs. Maybe we can see here the benefit because we are not using a huge amount of the memory space. But if you will be very professional, we write a huge code, memory space management, it will be a very challenging point, and it is a really challenge to us. Especially suppose that this happened with us when we are talking about, for example, a software that dealing with, example, image processing. Why I said image processing? Because suppose that you have an software that is going to make an object detection or face, like now you see many applications that make a face detection, how we can know the face of the person and video. You know, this is a processing of such kind of program, how much memory space is needed, because a picture for us or for the computer, it is a set of pixels, and each pixel will hold a value. So if it is, for example, 124 by 124, so it is more than 1 million pixels. So you can imagine about the huge amount of memory space we needed. So sometimes if you are going to deal with video editing, you can see this video editing software, your computer will die because it needs a very huge amount of the temporal memory space that you will have it. And sometimes many computer will freeze because it's the memory space is being somehow overloaded in this case. So when you are going to write a program that deals with image processing and video editing, the memory space management, it's a very key point and very challenging, and it's not easy how you are going to manage it, or your program will fail. Because if you don't manage in a very good manner, most of the devices, where your software is being installed, will not work in a good way. So this is why about talking about memory management, it's a very key point for huge programs, and then you are going always to take care for this. This is the last question before we go to the group work today. The group work is a small one, it's not very a long one. So if you want to stay with the group work, I encourage you, you can get bonus, an assignment too. So before we go to the group work, these very short questions. We finished with the lecture. Sorry I didn't ask you about the break, but because this lecture is very related to each other, it is sequential, so it seems that we can't stop it, maybe because the flow of ideas will be this flow of idea maybe we will not go in a good flow. So this is why I didn't ask you to have a break. Sorry for this. I was excited to finish all the whole ideas with you, so I forgot. I'm sorry for this. But don't worry, now we're working with a group work, you can take much time and relax while doing your work. So we have two true-false questions. The first one is, dynamic variables or dynamic allocated variables in C++ are created and destroyed according to program need. True or false? It's easy. Dynamic variables or dynamically allocated. So Viraj, yeah, it's true. Our Brainy is not with us today, so you are with us. Yeah, correct. It's true. Because dynamic variable, the main idea from this is that we can create and we can destroy based on the flow of our program. So we create it when we need it, and if it's not anymore being need, if not anymore is being need, so we can destroy it in this case. You are correct. An array name is a constant pointer to array base type. Correct. True, false. An array name is a constant pointer. I'm not talking about dynamic array. I'm talking about the normal array, like integer A 10. So A in this case, it is a constant pointer or what? Can we name it a constant pointer or what? Any volunteer? Yeah, correct. You are correct. So it is a constant pointer. We have already said this during the lecture. So now let's go to the group work. Group work, you are asked to write a C++ program where the user is asked to enter 10 values and save them in an array. So far, it's so easy. However, you are asked to use pointers to calculate the maximum number is being entered in the array and print the memory address of all elements. So you will ask the user to enter 10 numbers, let's say 10 integers, and you are going to save them in an array. But however, you are not going to use variables, you have to use pointers. Using pointer, you will retain the maximum number that's being entered in this array, plus print out the memory address of the 10 element in the memory space. Like we do always, I will break you down to 2 rooms now. I will stop sharing the screen and I will send you the PDF file, sure, without the solution, for today's lecture.